place you can find the slides, so if you'd rather look at it locally on your own device, that's fine. Just make sure you turn off the audio. So this is me, and that's my desk, and so that's where I sit all day, and that's where I think of everything music and computers. So my day job is doing something called Sight Reading Factory, and we teach middle school and high school kids how to read sheet music. And it's a kind of cool interactive app. That music that you see is generated by us, and we also generate the sound. And so if you or your loved one wants to learn sheet music, please go there. And that's a great fun resource to do, and it definitely works. Then this is the thing that kind of got me into computer music. I created this open source project called abcjs, and it's a way to just create the visual music on the screen. And it's really nice to have a synthesized audio to go with that, because it's a good way to check your work to make sure you didn't do a typo or forget a sharp or anything. The synthesized audio is never going to sound great. Like, it's always going to sound computerized. So there's a limit to where you can use this. You can use this definitely in any kind of learning situation. You can use it for checking your work. You can use it for arranging things to say, well, here's what it's supposed to sound like, generally. Now let's go do it the way we really want to do it with expression. But there's a lot of things you can do with those sort of the MIDI kind of format, but it is kind of limited. But so anyway, this is where I got interested in doing audio. And so the thing is, like, let's say you want to create music. There's just a couple ways to do it. Like, you could create an MP3 and put it on the server, and you could link to it. And there's a couple limitations with doing that. First of all, you have to know what you're going to play in advance. There's no way to do interactive music. There's no way, you have to decide what you're going to play. Or the server has to, when you make a request, the server has to generate it right then, create the MP3, save it, then pass back the link to you. So there's a lot of problems with that. There's also things with our app. If it's used, our data center is here in Virginia. If it's used in Europe or something, it can sometimes take multiple seconds, like, to go get an MP3, because it's just, it's just going to be a slow way to do it. So if you could do it in the browser, that would be great. And so this is an example of creating in the browser. So this music is just created on the fly. It's using the abcjs library, but the actual thing that created this music is this tiny little, it's a string of maybe 100 characters, and that's all you need to do for the input. And that sounds like, so notice, like, I have this all cached because I'm definitely not trusting this network, but but so you'll notice when I hit play, you'll get a little spinner, and that's how long it takes to create the music. It's pretty quick. If you want to experiment with this, like, if you go to these slides later and actually do this, you'll actually have a more idea of how long it takes to create it. But yeah, there wasn't so there wasn't even a delay that you could even see. So yes, that was I decided to put that in B flat just so it wouldn't be too easy. I mean, probably nobody's ever played this tune in B flat before, except, well, horn players have, but they wouldn't have read it like this anyway. But I actually wanted to show off. I drew that little flat symbol, so that's the extent of my being able to do anything with fonts. So anyway, you'll notice a few things. We had the progress bar going across. We had, the little cursor going along with the music. We had a couple things going on. We had, like, the piano accompaniment, and that all just came from figuring out, a boom chick kind of rhythm that goes along with, with the chord symbols that I put up there. So we can also do more stuff, like this is an example of what you would learn if you got Sight Reading Factory. If you played piano and just picked one of the exercises, this is something that might come out. And so the music can be as complicated as you want. You can do as much as you want. I tried to actually find a limit a little bit, like, well, let me do 32 voices at once. Let me do, and it seems like it doesn't matter. It all kind of boils down enough. Like, I have been able to find a few limits to what you can do musically, but they're not really practical. They're not, I doubt anybody would ever actually require music that does that. Like, I created this tune that was, I called All Notes on All Instruments. And, and that took about 5 minutes to load, but it actually played. But you just saw this, like, but anyway. So this is what I've tried before. When we first created this, I created abcjs with a partner, another programmer that I met through a list who was actually doing the same kind of thing, and so we just decided to create one package. And he figured out, like, you could load QuickTime. I don't know if y'all are old enough to remember when you could actually, embed objects in browsers, but that was just fine. It was like a real easy way to do it. There were some limitations to it, but it worked. We could get the sound out, and all you had to do is format it as if it were a MIDI file, which is a pretty easy standard format. And so all was good until QuickTime upgraded to 7, and I guess not enough people were using MIDI, and they just, decided to drop the support for it. And then even later than that, the browsers stopped allowing you to use QuickTime in the product. So that was that. So then the audio control was coming out. It wasn't generally, it was available in a lot of places, but it wasn't really universal, so it would only work in certain places. There's also, I tried to actually make it work and fit it in for at least those browsers that worked, and it wasn't performant enough. You can't really control exactly when the sound comes out. There's not, I want, like, to do all that stuff I was doing with the animation, I need to know exactly when that note is happening. I don't want to know approximately. I just, and I just couldn't control it enough. And so that just wasn't able to do it. So then I found this really cool library, and I thought the problems were solved. I would just link to this library, and that would all work. I got this one comment from somebody, emailed me, saying, it works pretty good on my computer, but when I tried to do it on my phone, I would rather actually hear silence. And so it was one of those things. So it did, it had a whole bunch of different ways that it would hack sound. If your browser was new enough to have the AudioContext, it would use it. It would be reasonably good. It also wasn't sort of designed for what I was doing, so there was a lot of inefficiencies that really didn't have to be there. So I didn't end up doing it. But so what I wanted to use was the AudioContext. And it only requires a few things. It's kind of like you can pretty much count on it these days. So you need the AudioContext. You need support for that. You also need, because of all the stuff that browser's done to try to keep ads from auto-playing, you also need to resume, and that wasn't in the early versions of AudioContext. But you can get around it. Like promises you can autofill. Resume, you could write the code twice, basically, in case it has it or not. MP3s, I decided, like, there was fallbacks for that I could use, but there was no browser that I know of that did not support MP3 that supported the other stuff. So might as well, why bother doing any complication for that? So really, you can get by with just using AudioContext. I decided to require, you also need to have a newer audio context that also has resume. And you can see where that is. Audio context like Firefox 25 and resume came in Firefox 40. Because it auto updates, there really aren't that many people in between those versions. There's not that many people who are using those old things. Although you'd be surprised, we definitely are watching our browser statistics, and even like middle school kids and high school kids, I just can't believe how many browsers there are. I thought there was like 5 browsers, but there are just, it's just incredible how many systems people end up using. So anyway, here is a summary of that chart. This is the what you need to support this. And you'll notice that in all cases, by about mid-decade, it was pretty available. So I would say that as long as you can convince them that IE isn't important, then I think you are okay for this. There are definitely there's places that it just doesn't work. Like there's sandbox browser things that you get on certain phones and certain places that, like, we just run into all kinds of weird things. But if on just the standard systems, everything works fine. The other thing is that recording uses the same kind of thing, but recording is it's a whole nother subject. I mean, maybe that's like another talk, but that uses the same basic technology. Theoretically, it is possible in both cases, and we have done it. We do that in our product so that students can record what they do and then upload it to their teacher. But that really opens up a whole bunch of issues. So some other talk. So this is the only thing I'll quote out of the official documentation. This, I think, is a completely true statement. I really love the last phrase. It's like difficult to start it if you are a developer. It's like, who else is going to use these I can't. I'm not exactly sure. Well, I guess it's even more. It's probably impossible to use if you're not a developer, but I guess they didn't. But so anyway, this is the entire inspiration. Like I searched around for things. There are some good tutorials. To figure out which ones really work now that things have changed, it's a little bit difficult to figure that out. So this is our path. I'll try to get through this with as little glazing over of code as possible. So we saw the beginning and the ending things, and so this is the steps we need to do to get to the actual music. So first we encode it. Like this is that string. This is the entire tune that we saw is in the code part, and you'll see the highlighted part just shows you, like, this is sort of a different topic, but this sort of shows you where it is. This is all you need to have is this string. It turns the quoted B flat into the B flat chord, and it has a B, B, F, F notes, and it shows that as the notes there. So that's pretty much all the format you need. That's all the input you need to do this. And then what I wanted to do is I need to turn that into a series of events. So for that tune, I need to say, well, I want this note to start at this time and end at that time. And here's all the list of notes. So here's an array of all the notes that we have. I put them all in just so you could see how much it is. But so we have the melody track and the rhythm track, and you can just see that we define a pitch, we define an instrument, and a start and end time, and those are relative times. Those are measure like 0.25 is a quarter note, and that's so we can add the tempo later, so we can use whatever tempo we want. And so that's pretty much the input. For after we've processed it, this is the input to the audio system. And it's just like, I want this note to play for this amount of time. And you'll notice that the first note ends at 0.242 and the second note starts at 2.5. Otherwise, the notes are all slurred together. You want to have the punctuation. So you need to get an audio context. The biggest problem with audio context is that there are finite resources. Like you create a new audio context, you use it, and then you let it get garbage collected, and you create another one and use it and let it get garbage. We don't know when garbage collection happens, and I wish you could say just garbage collect now, but there's absolutely no way to control that. So you can run out. If you do that, you'll just run out of AudioContext, and randomly, it'll start returning you an error. So, and also, this is every tab. Like if you have this open on 10 tabs, you've used 10 AudioContext. So you can easily run out of these things. And it's not just you. I mean, YouTube is using one of these too, So if you have YouTube open on another tab, you can just start to run out of these resources. So this is just a really cringy way to create a global object. I'm just, I don't ever do this, but don't write to the window object. But, this is just a good way to create. So, if you have one, you use it. If you don't have one, create it. And then, that's just get it through that. You still have to use browser prefixes a little bit. When I first wrote this code, you actually needed 4 things there, but Opera and Firefox dropped it. So we're getting close. But that's not a big deal. I mean, it's easy enough to do. So the other thing you need to do is you need to see if the browser supports what you're doing. And so if you try to create an AudioContext and you create it, and the AudioContext has resume on it, then you're good to go. Like all those other requirements will be satisfied, so you're fine. So now there's a way to do synthesized sound. There's a lot of different things built in. They don't really sound like music. They're just kind of effects, and they're cool effects. But if you really want to sound like a piano, you need a recording of a piano. So if you think of each note on each instrument as a character in a font, that's your sound font. And so there's a repo, like I cloned this from a MIDI.js one, and then I had to do a couple additions to it. But this is basically the MIDI.js one. And this is just a collection of MP3 files that has every note on every instrument. And so you have to do this with an HTTP request because it's binary data. And then you just format, you have what instrument, what note is, and you just format the path to it. And then you just, when it returns, you just store that in a cache. And so I have, as soon as you ask for a note the first time, I cache it. And so you don't have to keep going asking for that note again. And most music is pretty repetitive. It doesn't have that many notes in it. Like a typical folk melody will have like an octave and a half of just things in the scale. Then if you're playing chords, it might be 3 chords, and that's going to be, 4 more notes in a different octave. It's just not very many notes in all for simple stuff. So now this is the meat of it. So now that you've got all this stuff set up, we need to create an audio buffer. And this is actually just an array of numbers. And those are the samples. So if you have a CD, has the 44K samples per second, that just means that there is a number 44,000 times a second, and that's just a volume to move the speaker. That's just the voltage for the speaker. And so as the speaker jiggles, it moves air, and it's just doing it at that speed. And so all you need to do is have a set of volume numbers, 1 for each sample. So we create the buffer, and you have to figure out the length, which is the time you want, and you figure out, it's just a little bit of arithmetic. But then, for whatever reason, it's a 2-step process. You create the buffer, but then you have to go get the array out of the buffer. But that's all it is. It's like, so now Chan data there is just an array of numbers. And so you can just write to that like you want. And then you kind of figure out the tempo you want, and that's just some more arithmetic in the back. And then you just have a start and end sample, and you find the pitch, get it out of the font, and you have to do the same thing. You have to get the buffer from that, like you have to get the actual array from the buffer. and then you just simply write it into the channel data. Now this is the absolute simplest. This isn't like production code, because there's more to sound than this. If you didn't worry about the volume stuff and you were just copying it in, it would just be exactly the same thing, and that's fine. When you're processing sound, there's more to think about. This works reasonably well, especially with one note. If you do two notes, you can actually add the stuff together, and I was sort of experimenting with it, and it works all right, like if you say, add the two notes together and then maybe take 75% of it, and then, and that works for maybe 3 notes or so at a time. But you can do filters, and that's beyond this talk about how to do that, to actually figure out what the exact right thing to put in there is. So that's one of those things that, that may be a future talk. So I also wanted to show you how I was really surprised when I created these controls, how easy it was. To create that triangle is just that much code. It's just one polygon. And when I started, I was thinking this was going to be a project, and then when I got into it, I realized, oh, the standard controls are just really simple shapes. The pause button is just 2 rectangles. The spinner is just a circle, and you'll see the dash array thing to make a little chunk out of it, and then you just animate that. This is just 2 elements. It's a button so that the user can click anywhere on that larger rectangle, and then the smaller thing is just an absolutely positioned thing that just has a background white. So that's basically all it is. That's all the preparation we need. So then when the person wants to actually play the music, you'll have this function, and you give it the audio buffer that we created in that last step. You can also tell it when to start. You can start now. Usually the applications I do is start as soon as you can. And so you just put a 0 into the start when variable. And then you can start where, if you pause it and start it, or you have the user click in the middle, or you just, for whatever reason, you have a selection that you want to play, you can actually say, well, start at the 3rd second. And so you have a good control over that, and you don't have to make the buffers more than once. If the user resumes, you don't have to make a shorter buffer that just has the resume part. You can just reuse the standard one. So then there's this other thing, this is one of those things that's why do we have all these weird objects? But so you can't just use the buffer you used. You have to create a source buffer and then copy that buffer into it. So these source buffers can't be reused. They just get thrown away. As soon as you hit start, you can't access them anymore. But for whatever reason, you can reuse the audio buffer, but you can't use that source buffer. So then you have to connect it to the destination. The destination is your speakers. You don't have to control over what that is. That's whatever the system is set. If the user goes into their preferences and says, I want to use the external device, or I want to use whatever. But this is where you can actually add other stuff. You can add filters to equalize it. You could add filters to fuzz it up. You can there's all kinds of computerized things you can do, and this is where you add anything that you would do in your sound system. This is the point you would do in between those 2 things. So instead of connecting to the destination, you connect to another filter, and then that filter connects to the destination, and you can chain all of them you want there. Mostly just for the simple music that I'm doing, especially because the main use of this music is oh, here's some sheet music. What does it sound like? I'm not really trying to do production quality sound. This is all I ever need to do. I don't need to worry about those other filters. And then you just simply start it. So you started your source. It's got all the chains set up. It'll start when you say, and it'll start from whatever position you want. Then it doesn't have a good way to tell where you are. So you just have to do your standard animation, the request animation frame. And I've got another object, which I didn't show you, that I built from that same music that says, here are the time periods that I need to do particular items. One thing that we do is, like, if we have long music that scrolls, we actually scroll the music early. Like when you get to about a second before the end of the line, the music scrolls up a line. And so all that kind of stuff, you're going to need some kind of animation. If you're doing this kind of app, it's very likely you'll at least want to move that thumb thing, the progress bar across. You might want to do something with the music. You might want to do other things that happen. So, but that's a completely separate step. I don't think there's a real good, reliable way to do that. Get the events right from the buffer. So, because of the browser's way that it doesn't want autoplay ads to happen, you have to create the audio context exactly inside a button click handler, or a user interaction handler. So this is kind of just some the kind of pseudocode. This is how you might do it in Vue. Like, frameworks don't really want you to, frameworks are more like you click a button, you set a state, and now the application reacts to that state. And so to do that, you have to, when you click the button, you still have to create the auto context right then. And you still have to resume it. If something else on your page or whatever had suspended it, you might have to resume that audio context or you won't get any sound. So then after that, you're cool. You're cool for the rest of the running of that app. And so you can do like, okay, let me just set my state now, and then later on something watches that state and it can do it. So so that's the kind of the important thing, is to make sure those two lines are actually in your handler. So you'll notice, like, I sort of marked the browser differences by browser, and this is actually just a few of them. Like, I just typed this off the top of my head of what I've been worrying about recently. You can't control the resolution. There's like one resolution. You can modify it, except in Safari, in Safari you can't resample. In other browsers you can. So if you want to, like, for instance, if you want to create something to download, but you want to download it at 48K, well, you can do that, but you can't do that in Safari. Then there's a whole bunch of other things that happens that you just have to be aware of. So it's not quite, it's still kind of moving technology, and but I mean, it works pretty well. So as I said, the biggest resource is AudioContext. Just get one of them. Now this is just using the window performance memory object. You can see what I'm using right now in this browser. If you just, like, it's very, of course I lose the cursor. All right, so it's really changes a lot. Like, it's hard to say when garbage collection happens, or why, like, it took 10K to click the button when the button didn't do anything but rewrite that to the screen. But that 10K gets gets garbage collected, and it's not like a cumulative thing. But so, from what we've done so far, and actually more than that, because I cached everything, as I said, before I started. But this is an example of, like, just all the piano notes. So if I do this, theoretically, if you do this, if you look at the slides, there's like 88 more notes that I've thrown into the cache. It's going to, like, you noticed before when the numbers were sort of changing randomly, the numbers, it's sort of noise. I mean, it's not even amongst, it doesn't really change anything overall in terms of the browser usage. So I don't think that, like, loading this, I was originally going to create this whole cache system for, how to get rid of the old notes. And I'm just like, well, in practical terms, you really don't have to. I guess if you're having a user thing where the user can create music and the user creates, does your crazy all notes and all instruments thing, then maybe. So There's other problems, like latency is a big thing I've had to worry about. Most of what I showed you is like setting up the buffers and getting the actual sound, and so that you can control. And so if you just create all that stuff before you get ready to hit start or before anything else in your program, thinks you've started, then you're all right with that. But there's also unpreventable stuff. There is a super accurate timer on the AudioContext called current time, and it doesn't really matter. Like, who cares what the browser or the AudioContext thinks is the current time? What you care about is, did something appear? The current time to the user is when they saw it on the screen. The current time to the user is when they hear audio come out. So it's like this, there's this whole thing about relativity and trying to measure it. And like, so what that you've got the current time here? That's not really what anybody is actually using. So the recording has a latency, the playback has a latency. And I did this cool experiment. I did a bunch of experiments. So what I did was I started recording, and at the same time I started recording, I started playing a buffer that had exactly one tick, metronome tick at 1 second in. And then I also took a filter, and exactly 1 second in, I created an oscilloscope or oscillator, and I put it right onto the file. And you'll notice all the way to the left, you've got 1 second, and there's nothing. And actually, it knocked out a little bit of the slide, but it doesn't really matter. So right at the 1 second mark towards the left is where those things should have happened. But where it actually happened, like where the sound came through from the recorder, is at 1.64, 64 milliseconds later. And where the tick happened was actually at 109 milliseconds later. So those are things you can't really control. When the playback comes, there's a lot of stuff in between it. If you've got Bluetooth, if the user has Bluetooth on, who knows when they're going to hear that sound? There's absolutely nothing you can do about that. And this recording thing, I thought I could actually control for that, but I can see that, like, even on my computer, which is a fast computer, it doesn't really, it still has a lot of delay, and this delay is different every time. This is just one example, but this is fairly typical. So I wanted to show you what the delay looks like. So I created this file, and what this file has, it has a piano accompaniment, has a banjo lead break, it has two people playing wood blocks, and this is what it's supposed to sound like. So that's everything completely synced up. So let's see what happens. Like if I just did the delay without doing any kind of this is the delay we saw on my computer in the last time. So this is what happens if I delay one of the wood blocks and the banjo by as much as would happen if I just said, okay, I recorded this buffer, now play it back at the exact same time that I thought it was. So that's what 100 milliseconds sounds like. So obviously, like, the latency is like hugely important. And you can hear, like, there's some kind of interesting effects. And I spent too long playing with this. But here's like half of that. So basically, if the banjo wasn't late, it kind of has a cool gallop thing. Like, it's kind of, I mean, it's sort of like, wow, I kind of like that one. But so what's acceptable? Like, so, like, here's 5. So you can't totally tell unless you hear them side by side, but just it was just a little thicker. The beat was just a little thicker, but it's okay. Like, depending on what kind of music you're doing, and really electronic music is very precise. It probably matters, but a lot of music, when I've been in a lot of jam sessions where people had more than a 5 millisecond delay, so it just sort of all depends on what you're doing. So and anyway, you can use web audio, and so some restrictions apply. Contact me if you're interested in audio. I love talking about this, and actually I put this together because it was something that I needed to learn. So I feel like I'm a really beginning student on this. And as I put this together, I found all these new topics that I could have been talking about, but obviously I didn't have time anyway. So also abcjs is open source. I'd love to have some help with it. The original partner got his PhD, and he now has a real job, and he actually spends all his free time dancing. So anyone who doesn't have those things, please contact me if you want to help out. There's a lot of really cool stuff left to do. So thanks for listening.